Good morning and welcome thanks for joining us today for our monthly Lean Focus webinar series. Today's webinar will be covering the topic of design for manufacturing, unlocking your product's full potential. My name is April Lee and I'm the Managing Director of Lean Focus. Our presenter for today is George Ellis, our Vice President of Innovation, who'll be taking us through the intersection of design and its manufacturing counterpart, helping us assess a seamless way to bring quality, form, and function to life while reducing wastes on its manufacturability. The symbiotic relationship of these two processes are crucial, but often overlooked in the day-to-day business grind. So before we begin, George, if you don't mind skipping to the next slide, just a reminder that today's presentation is the proprietary information of Lean Focus and should not be used, disclosed, or reproduced without the consent of Lean Focus. Title in and to this presentation and all information contained herein remains at all times in Lean Focus. So on the next slide, you're going to see some quick webinar logistics. You are in listen-only mode. There are some PDF handouts made available to you in the control panel to support this topic that you can download. A question and answer segment will be held at the end, so please go ahead and type any questions you might have into the chat function for our presenter to answer as time allows. And lastly, a recording of this webinar will be emailed to you about a day later, but you may need to check your spam folder if you don't see it right away. So with the next slide, before we begin, let me go ahead and share a little bit about Lean Focus, who we are, what we do. So Lean Focus helps our clients transform cultures into high-performance cultures by helping with training, coaching, and sustaining results using our proprietary Lean Focus business system tools and processes. We focus on developing and placing driven leaders, either through training practices or our executive talent solutions services, who specialize in recruiting and placing top lean talent. We stress that change management is a key element of culture sustainment. So we help bring that continuous improvement mindset and the ways of working with us. And lastly, we apply our proven systems through both our implementation methodology as well as licensing materials for companies to be able to achieve these same results over the long term. On the next slide, we'll just show you some of our 8 practice areas of how we help do this. So what we really look for is helping to drive lean growth, strategic improvements based on your unique industry, your challenge areas, product types, and organizational needs that you may have. Our team comes from leadership backgrounds that help you navigate and assess your strategy at a holistic, enterprise-wide perspective, with an ability to drive down and teach associates how to implement and sustain those improvements on their own. We specialize in the culture transformation at all levels of the business, pulling from the expertise of our commercial, growth, and lean practitioners, private equity, senior leaders, and talent solutions professionals. So on the next slide, we'll just show you some examples of companies that we've helped build this high-performance culture with. And as you can see, our methodology is industry agnostic and can be applicable to any area of manufacturing, operations, and commercial areas such as sales, marketing, innovation, growth, you name it. We help clients identify what strategic objective they're trying to achieve, and then we can apply the right approach and lean tool to help get them there. So on the next slide, I'm going to show you our proprietary Lean Focus business system tools. Now, I know this is very hard to read, but there's a lot of tool sets that we apply when we're looking at some of the challenges within your company. And what we try to do is help identify what are the appropriate tools of what you're trying to achieve. We help you build a sustainable culture with common lexicon and process-driven approaches to help you realize those results. These materials can be licensed as well, so we can help you build a lean business system out of the box that works best for your company so you can hit the ground running immediately and drive culture of continuous improvement, people development, and performance achievement. So with that being said, I'm going to go ahead and turn this over to our presenter, George.
And yeah, thanks, April. Thanks for everybody for joining. And we're going to talk about design for manufacturing, our toolkit today. And just my background is I'm an R&D. I was in R&D. I was a single contributor for many years with Danaher, and when it moved into leadership, starting in about 2010, and was able to go into leadership and apply lean principles in innovation. And it was just for me, like just watching it happen it was just amazing how it changed people. You'd have the same group of people, and their performance was improving, their results, you know, trailing a little behind that, but improving, no doubt. Their engagement improved, and how much their satisfaction with their jobs. And some people wanted to grow and be leaders. Some people wanted to really become experts in their field and master their craft and in the technical areas. But look, I just watched how lean thinking cut waste and let people go do the things that they want to do, that they've learned and trained how to do, and that the company needs them to do. And so I just fell in love with it. I'm so grateful to have a chance to join the Lean Focus team about a year and a half ago, and just be able to spend you know, time doing this all the time now. In terms of what we're going to talk about today, I'm going to talk a little bit about innovation lean. And those of you who join me for webinars, you know that I always talk about this a little bit, because lean is so misunderstood as being a factory tool. It's not. It's so much more, and we'll talk about that a little bit. And then we'll talk about the four tools in our toolkit for design for manufacturing. So we have you'll see the four down here listed, and then we'll talk about them each. Today's session is really packed. It's more slides than normal, so I'm going to go through the introductory stuff faster than normal so we can get to the meat of the discussion. So the first thing I like to tell people when they ask me is, how does lean work with innovation? Because, you know, a lot of folks show up when they teach lean and they'll say, oh, here's how we do this in a factory. Here's how we make a U-shaped cell. Or here's how we do a pull system using Kanban in production. And that's how you are. And if you're a person who's in design, or development, or any of the innovation space, that doesn't feel natural, because it's very hard to see how you're like that. And I have the greatest respect for factory people. You know, whatever company you're in, the people who work in the factory put food on your table. And so that's a tradition from Taiichi Ohno that they deserve the greatest respect. But what we do in innovation is just different. It's not better, but it is different. So, you know, I'm often asked this question, you know, and so I say, you know, we interface at three places. First off, we interface at the annual level. If your company has a strategy deployment cycle, or even an informal strategy, but somewhere along the line, someone in your company is looking at the big picture for innovation, and they're asking you, like, what can we do to move the company forward? And 9 times out of 10, it's grow revenue from new products. And that might be through bringing in new technology. It might be through better product development. It might be through better launches. But these are the typical things that when you really think at a high level, a strategic level for the company, this is usually what you're thinking about. The next place that lean interfaces is like the sort of thing we're going to talk about today. Sort of this monthly cycle where maybe we go in and do an assessment and do some planning, and create some metrics, but then we're into tool selection, tool deployment, and we go through the cycle of, I need that tool, like design for manufacturing or FMEA, the things we'll talk about today. You know, that big list that April showed you a few minutes ago, those are all tools. You bring them in, you typically bring them in on a maybe 3-month cycle, you know, bring them in. Takes a week to bring them in, but then it takes like a month or two to really learn what you're doing and make sure it works, and then we go get the next one. So it's like building a set of stairs. We just keep getting higher and higher in performance, and we build them one at a time. That's why it's continuous. It never ends. You never learn everything. There's always more to learn. There's always places to improve. The last place, and a lot of engineers, software developers, they're really surprised to hear me say this, it's about problem solving. Because most engineers, my experience has been, engineers are not natural problem solvers. You might be saying, wait a minute, that's crazy. Look at all the problems we had to solve to get to where we are. You know, just going through college, you solve a bunch of problems. But that's not what I'm talking about. When you go to college, the professor hands you a piece of paper where it has a problem stated on it, and you solve the problem, you get it back, and you got it right or wrong. But in the world that we live in companies, the problems are so much more complex. There are so many more unknowns. It's not a closed problem. It's more like you have a problem, and you really need a cross-functional team to understand that problem. And then you're not going to solve it. You're going to go create some solutions that you think will work, and then you're going to measure them for 3 months to see if they really did work. That's real problem solving. It begins with daily management. I say daily. For us, in innovation, it's usually weekly or monthly. but we're tracking something and the bottom falls out of a graph like you see going here. And then we go over and we bust into problem solving, and it's a cross-functional, lengthy process. So so we teach that, and that looks very much like what happens on the factory floor. Some of these diagrams are straight out of the factory floor, as a matter of fact. Although our problems are different, our representations are similar. But the point is, all three of these areas are places that anybody in innovation can use lean thinking to improve the performance at the output, and as I said, master your craft and grow in leadership. So it applies in all areas. So these are the tools. April showed you a whole bunch of tools. These are just the tools that we have that are really focused around innovation. And and we're going to be talking about the design to produce toolkit today. So design for manufacturing is one of those, and then there are three others. So, but it's just, if you look at where we are in here, the design section of innovation, that's the heavy lift. That's where you spend 80% of your money, or depending on how much sustaining you do, but maybe 50%, 80% of your money, depending on the organization. Out here and building a roadmap and defining projects, they're important, but they're not expensive. But this is where you're putting together the teams of engineers for long periods of time, and software developers and chemists and all of the technical people, as well as the commercial people who are down here planning the launch readiness. This is the heavy lift. And what we're going to talk about today in that heavy lift is the design to produce toolkit. In other words, up here I might have a phase gate system that has my requirements, visual project management that gets my projects on time, user feedback where I'm learning how to interface with the user on a continuous basis, and commercially ready. But what makes me ready for the factory? That's what we're going to talk about today. So let's talk a little bit about problem solving. Whenever we talk about problem solving, we always separate the symptom, things that are obvious but hard to quantify, like I'm tired, I have cold chills, I have a headache. A problem, something measurable, I can't treat it directly, but it tells me I have a problem, like a temperature of 103. And then there's a root cause, something that I can treat, but it's hidden. So in this case, there's a perforated appendix that needs to come out. And the reason why do we say it's hidden? Well, in lean thinking, we believe people are basically good and they want to do the right thing. If they saw something was wrong, they would just go fix it. What is left is all the waste that we don't see, and there's lots of it. And so when you think about root causes, that's where we can take action, but we've got to study the problem so that we can see where those are, because they're not obvious. And if we go digging in the wrong place, it won't do a bit of good. Taiichi Ohno, the father of the Toyota production system, which evolved into lean thinking, he said that if we misunderstand root cause just a little bit, our countermeasures will be totally ineffective. And so that's why we study problem solving so carefully. So let's talk about design to produce. So if we look at the whole design to produce structure, first off, it's all built on a strong phase gate system. Why do I say that? Because if you don't have a phase gate system that makes sure that as you're progressing through the development of a product, you won't deploy these on a reliable basis. You know, you'll have some great project managers that go pull these tools, and then you'll have some variation, maybe somebody new to the company or maybe somebody that just doesn't understand. So you need a great phase gate system to plug these tools into. So the phase gate system, that is, you may have heard of the term value stream map that people talk a lot about in the factory. You know, everything from I bring in parts in the incoming, and I ship a completed unit in outgoing, and everything in between is the value stream. Well, for us in innovation, our value stream is the phase gate system. That's what tells us what we have to do to keep elevating the value of a project. You know, a project that's an idea that might make millions of dollars is not worth nearly as much as a developed product that might make millions of dollars when I launch it next week. I haven't made a dollar off of either one of them, but the value of them is really different. But so the phase gate system, it's our value stream, and you need to be able to plug that in. And these are 4 tools that we want to plug in, and I believe they belong in any company that relies on manufacturing. Now, if you're a software-only company, you have equivalents of these, but if you're shipping any kind of hardware from small to large, if you're doing it through a contract basis, and you have somebody doing a lot of the work for you, it's really not relevant to the question. You need these tools. So let's go through them one at a time. So first off, there's failure mode and effects analysis, which is a structured way to find and improve shortcomings. And there are two kinds of FMEAs. There's a design one that we use earlier in the product development process, and to help us get the design right. And then we use another one later, which is the process, or PFEMA. Sometimes, even though it's not spelled this way, people often will call this FEMA, even though it really is spelled FEMA. Anyway, a lot of times these are called DFEMA and PFEMA. And I'm going to tell you, these aren't the most exciting events. You know, I'd much rather be in a user workflow discovery or a road mapping event where you're talking about all kind of new stuff, or technology road mapping. But these things are so important to get it right. They're part of the diligence of engineering. The next one I want to talk to you about is value add and value engineering. And this is a structured process. And you're going to see me say that a lot, structured. And all of these things are structured processes, and they're all cross-functional teams that are executing them. And what you're doing is, in this case, is you're looking at the cost, and you're looking across the function of the product and ensuring that the cost of the components is right-sized. So so that's a whole, as I say, that's a structured way to ensure that the cost of what you develop and launch is in the right place, but it's also a tool you can keep reapplying to a product year after year, because there's a dynamic that switches. When you first release a product, you might only be making a handful of them a week, but 3 years later, you might be making 25 times that. So they become, each time you increase the volume of what you're doing, there become different opportunities. So value add, value engineering is something that can be applied to a product long after launch and at a regular basis. That's the only one of these 4 tools like that. There's design for manufacturer, which is what I refer to that. What I mean is where we have a structured method for subject matter experts to give us expert guidelines that everybody in the company can use. I mean, think of it as leveraging. Who's your very, very best optical engineer or chemist or electrical designer in your company? Well, you want them to be laying out the guidelines that everybody follows. And so you leverage this really towering technical expert, the SME or subject matter expert, that across the entire company, versus people having to find it through tribal knowledge. So, and we'll talk about that one. And then the last one is the production preparedness process. And that's where you find a specific problem that you're going to really go address. And it's a kind of a problem solve, really oriented towards technical issues. You know, there's lots of problem solving in lean thinking. And the 3P is one of my favorite for innovation. I used to use it all the time. We would run, when I was running an R&D group, my last functional leadership role, I was running an R&D group with about 100 guys in it, or excuse me, not 100 guys, 100 people. And all over the world, and we were doing 3Ps once and twice a month. We were doing them constantly. We were doing short ones virtually over a few days. We had big ones where we got teams together, and you know, a lot of people would fly to Europe. It was such a powerful process, and I see so few people use it, and it makes me sad, because it makes your products, you know, it just gives you so much. We'll talk about that. And then finally, as I said, everything is based on the foundation of a phase gate system. Without a strong phase gate system that's deployed and used and active and living, these things are going to disappear into the other 300 things I have to do to create a project. So I don't want you guys to think for a moment that we can look past the phase gate system. We're not going to talk about it much, but think of these as plugging in and then giving us requirements to check against, and then see what they become. These become standards in our organization, the level that a product must achieve before we will put our stamp on it as a company. So let's talk about FEMAs. So first off, a typical FEMA is 3 or 4 days long, depending on the complexity of the design, even 2.5 days sometimes. There are 2 major types, design and process. I've seen other kinds, safety, system. I've seen other kinds of FEMAs, but these are the 2 major types that are used. It's always got a cross-functional team, and it's almost they're mostly technical, but you always want to get manufacturing involved in any kind of a FEMA, because they can tell you so much about the effects of the failures that they've seen. And so you want to, I would say, most design FEMAs are 80% technical people, design people. When you get into a process FEMA, the scales even tip more towards the factory floor. And the best process FEMAs always have a couple of people who are operators or techs or some sort of support for the line. Those people have so much knowledge that's lost when we ignore it. And I can remember doing a process FEMA just a few months ago, and we had everything all buttoned up neatly, and it all got busted when two of the people came in the next day, because we said we need some people who've been on the factory floor. They came in, and we had to make a lot of changes, and I'm so appreciative of them jumping in the way they did. A lot of knowledge out there. You want to get all that knowledge in your FEMA that you can. And you want to isolate the areas to investigate, and you're going to want to rate each area for the severity of the failure mode, the likelihood, and the detection. So let's talk about that. So when we come here and say, what does the FEMA do? So if you've ever come to my webinars, I love this tree. So what is a symptom? Hey, we get a lot of quality issues on new designs and processes that we should have been able to catch them. I'm not talking about the things like where something really complex came together and nobody could have imagined it. I'm talking about the stuff that happened a year ago and somehow we did it again. I'm not going to call it the stupid stuff, but it is it's not the smartest thing not to go out and check against the things we already know. So you don't use FEMA to go discover all sorts of things that you never imagined. It's more like get the experts in the room and go through methodically so that this doesn't happen. And so what do you wind up with? You wind up with a lot of process rework and design rework. Oh, we used the wrong fasteners. Oh, it turns out that kind of fastener doesn't work in this application. Because we had the wrong material matched up, or we used the wrong kind of plastic and it won't hold the tolerances that we needed. And we knew that. We knew that because we did this 18 months ago with something similar. What's the root cause? We don't have a method for a thorough and efficient team review. I mean, look, Monday morning, every engineer knows Monday morning quarterbacking is easy. It's so easy for everybody to come in and say, wow, what a stupid thing you did. We knew from 2 years ago you shouldn't have done that. But if you don't have a structured way to do that, how do you get everybody in the company performing at the same level? Just if the guy who happened to know it happens to look at it, he may tell you, maybe, a lot of people don't volunteer that stuff so often because they're not sure how welcome it is. Let's get an event where we have a structured way. And then we don't know how to focus on the most important issues. You get a bunch of people in the room and saying, guys, what could be wrong with this design or process? And people go to these crazy corner cases versus like, let's just stick to the center lane and focus on the things that we know. And maybe reach out a little bit. I'm not saying don't get a little creative, but you should be spending most of your time on things that you've seen or similar to things that you've seen versus a fishing expedition. How does a FEMA work? Well, we take we go look at every area. We might look at, say, a hinge and look at this hinge operating. And we might say, what if the pin breaks? Okay, so we're going to go look at the pin and we're going to say, what's the severity? Wow, if that pin comes out, this whole piece is going to swing out and it could actually be a safety issue. Or it might be if the pin comes out, the unit will just go into an error mode and somebody has to come back and fix it. So that would tell you whether, or if the pin falls out, that's actually redundant. It doesn't cause anything. So you'll score it on a basis of 1 to 10. And you'll do that as a group and everybody will talk and, you'd be amazed. In the beginning, there's a lot of talk, but, people sort of get the hang of it after about an hour. And you very quickly come to a rating as a team. And then you say, how likely is this to happen? 1 in 2 of my products are going to do it, or is it 1 in a million? And you rate it according to that. And then you say, could I detect it and stop? Could I detect that hinge breaking, have something out there that watches to make sure when the hinge breaks, and then just stop the machine? Well, that detection might stop the safety hazard. It's still not going to make the severity 0 because somebody has to come out and repair it, but you've taken the safety out. So 10 would be a safety hazard. Maybe I can drop that 10 to a 5. And then here's how simple this is. We just multiply these three numbers together and take the product. Now, and then what we say is there's a number of RPM that we will tolerate, and that number is typically 100. Now, this is the little cheat cards that we give out while we're doing FEMAs. So, how do I know whether to rate something a 1, a 4, or a 7? All of these things are defined. Like I said, in the first hour, it takes a little while. People are reading them, but after the first hour, you just start flying through issues. And so you step into this thing, and the first one takes you like 45 minutes, and you think, oh my gosh, this is going to take like 8 weeks. But after a while, you're doing them in 5 and 8 minutes. And so it just takes a while to get the hang of it, but it's super powerful. And then we take every single issue we found, and I've had typical number of issues that we found, maybe 150. That would be the number of issues you might go through in a DFEMA. Look at all the hinges and the bolts and the electrical connections. You might look at the shell, the outer shell for fluid being able to ingress, or you'll just go through issue after issue like that, and and it turns out to be like 100, 150. It sounds tedious. I'm not going to lie to you. FEMA is not the most fun event. It's tedious, but boy, what's more tedious is going out and fixing the problem on the factory floor after it's happened, or having to go change the design. So is it painful? Okay, I'm going to admit it. For 2 or 3 days, it's a little bit painful. But so much pain is solved later. It's definitely worth it. So we list them all, and there's maybe 100, 150. But how many do we have that have RPN over 100? Most of the time, there's maybe 20. It's not a big deal. Most of the time of those 20, 10 of them will fix right in the event. So we'll take some time in the event and go get that low-hanging fruit and start fixing stuff right away. And then the other 10 we'll deal with in the coming weeks. Don't think of it as something that's going to blow up your schedule. What's really going to happen is it's going to protect your schedule 6 months from now when that thing goes to the factory floor, and you would have been out there maybe having to take all kinds of, you know how hard it is. If you're in the design world, you know how hard it is to implement changes quickly. This will help you and help you spend time on the things you love and the things you want to master. So that's the FEMA. What can you expect? A lot less rework, absolutely. Also, as you're doing FEMAs, you're learning, right? Because the people who are doing FEMAs are thinking through issues they hadn't thought of. There's a lot of collaboration between design and operations, and you start learning what operations, the world they live in, you just wind up learning so much about the people that are building your product. And then that goes into early design. So now instead of catching them at the FEMA, I'm catching them in the guidelines, or I'm not even making the mistake. And so, it's just a virtuous cycle when you use FEMA. So that's FEMA. If you're interested in a FEMA, here's a little one-page sell sheet, and you can download this. And we've done several of them. I think we did 3. I think we did 3 in 2 months, if I'm not mistaken. It's a very popular event. And just it's all goodness. I just don't know a downside of a FEMA, except for, I'm gonna be honest, after lunch you get a little sleepy. So now let's move to value engineering. So what is this? We want to define all the functions of a product, and you can go beyond a product. You can talk about a service, an organization, a facility. You can do FEMAs on lots of things besides products that are made in a factory floor. We want to really establish cost function relationships to make sure that we're not putting in products that bring putting in components that are more expensive than they need to be and bring no value to the customer. They don't increase reliability, they don't increase quality, they don't increase performance, they don't increase functionality. They're just waste. And we want to go take that out. And it allows us to reduce costs of the product. And what does that do? Why is that a good thing? Well, it gives you more ability, if you have a tough competitor, to reduce price and maintain your margins and keep a healthy margin in your business. Or it gives you more opportunity to grab some margin, and more margin, some of that margin is going to go right back into R&D and fund new technology developments and new product developments, because we're not spending it on material that we didn't need. So, go back to our tree, our products are too expensive, and we don't act on known ways to reduce costs. And what happens is material cost rises over time. You guys have seen this, right? You design a product, you launch it, and then parts of it start becoming obsolete, harder to get, and costs keep growing over the life of the product. They should be going down. You've got so much opportunity to go in and automate parts of it, combine different pieces of the design into single pieces. You've learned so much more. You really understand the product well. You've got money now, right? And when you were doing the original design, you didn't have time. You didn't have budget to go get every little thing right when you got in production. But now you're out spending $100,000 a year on this set of components. Hey, I've got some money I can go re-engineer that with and save it. And so that's a wonder of VAVE. And why do we have these root causes? Same thing. We don't have a method to do it, and we don't have a formal process and the means to set like organizational targets. So I've worked with organizations where there's just a target. Hey guys in engineering, while you're out there doing those amazing new products, while you're sustaining our products, we also want to see X%, 4% reduction in material costs every year because you guys have gone in and done some redesign. Hey, take a little bit of that money you're investing and put it into cost reduction, and then that pays off every year thereafter. And so VAVE brings you these things. And so how does it work? Well, the pre-work is that you've got to figure out who's the team that can really do this, because it's very technical often. I mean, very often you have to get highly technical people in VAVE. You want to go redesign an optical system? You better have an optical engineer, a top-notch one there, to make sure you don't step in any holes that you need to miss. And then you need to understand how, you need to go out and grab the operations data, understand, how much are we spending, where are we getting stock out issues, where are we getting on-time delivery issues, what are the components that really need our attention. And then in the Kaizen, we're going to go through and do a functional analysis, and then we're going to a functional analysis across the product and really understand how it works. And then we're going to have a time of creativity. So this is a much more creative activity than say the FEMA, which is, like I said, FEMA's not that much fun. Great to do. I need to quit saying that. I'm going to be talking you guys out of it. And then we'll evaluate the ideas. We'll try storm and go try some ideas out. Maybe go out on a mill, make a part, say, or a 3D printer, try it out, make sure it really works. And then we'll set up a development schedule that might take 3 or 6 months. And VAVE often does take a long time to pay off for products that are in production. So if you've got something in production, you've got to go do the design, you've got to release it, and then you've got to work through the existing stock. So it's not unusual for it to take 4, 6, 7 months from the time from the time that you say, I want to do this, to the time you see the benefit. But remember, it pays year after year after year. As long as that product keeps selling, you are just printing money from these VAVE events. And then so what we're going to do in the event is we're going to pick the top, low-hanging fruit, that's most important to us, and report out, and then we're going to implement it. Like I said, this sustainment, it can be a half a year, but what a payoff, especially if this is a cycle. Think of it as being part of your organization. Every year we're going to cut so much % off material cost. Now let's say you pick 3%. Every year you're going to go get 3%. What do you think the benefit of that is over 5 years? It's enormous. So, this is such a powerful tool for people. And the way that it works is we look at the project objectives, we look at the one-time functions and the all-time functions, and we work our way through to look at and basically evaluating the functions that we need. And then we work our way down to unneeded functions, and we take those unneeded functions out. And so it's, again, very structured. We walk through methodically as we understand how the product works, how all the components work, so that we're able to go find those places. Again, we're not just cutting cost. We're not going to do something that's going to reduce quality, reliability, performance, or features that the customer values. So what we're going to be doing is taking out cost that the customer doesn't value, which is just waste. And so what can you expect? Well, our experience is that for every dollar you put into VAVE, you can expect $20 to $50 back. It's a huge payback over time. I mean, think about it. You have a product that's selling maybe for 4 or 5 years, you're going to go reclaim 10% of that material cost. It's enormous. And you also, typically in a VAVE event, you're also attacking quality issues. So another cost is a cost of quality. And if we know that there's a problem with a component while we're in the VAVE, we're going to go fix that. So quality and reliability typically go up through the VAVE process. Certainly they don't go down. And then you're going to get an R&D team. Again, they're going to be interacting with manufacturing. They're going to be learning. All of this is going to become knowledge that creates expertise in the organization, so that we're getting better and better at releasing products that are right costed. And of course, continuous improvement, it never stops. You're just always getting better at it. If you'd like to take next steps, same thing. There's a little simple one pager here on the VAVE. If you're interested in running a single event, and I really want to encourage you to do this, setting up a structure in your organization where you are actually coming back annually with targets and you're putting together teams. I've seen VAVE be very successful and take no more than a few % of the engineering team to do it. It doesn't take a big investment to go get that low-hanging fruit. So if you'd like to do either one of those things, set up a systemic way, and then after we have the system set up, which is actually relatively easy, and then we set up the planning, and then we do the events. And so we can do either one of those with you. And if you want to just try out a single event before you get started in something systemic for your organization, of course, that works too. Now let's talk about design for manufacturing. So I was always frustrated as an engineer that I would come in and I would, I'd come into a new organization and I didn't know all of the tribal knowledge. There's a lot of there were a lot of the older designers, and they had, when I say older, I don't necessarily mean older in age, although they often were, but they have been in that business for many years. They had huge amounts of knowledge. And, you'd have to go talk to them, and you'd have to make a special appointment, or maybe they weren't even in your organization. And, some of them were curmudgeons. They weren't that much fun to talk to. And some of them, they weren't that helpful. They didn't really know how to help. They weren't, you couldn't just go ask a simple question. There were all sorts of things that made it hard to learn what the organization knew. I refer to this as information friction. So think of information friction as I have the information somewhere in my organization, but I can't get it to the person who needs it. So I'm a young design engineer. I'm new at the company. I need the guidance from people who've been doing it a long time. How do I cut the friction by a factor of 10 of those people who know how to do this stuff? And so I go here to a wonderful book by Atul Gawande. I don't know if you've seen this. I want to say this is written maybe 2014, maybe 10 years old, but it's called The Checklist Manifesto. It's just an absolute fantastic book. He goes and shows how when brain surgeons, think about it. What gets harder than brain surgery? When brain surgeons have a checklist, the rate of people dying drops by, if I'm not mistaken, about half. Unbelievable. A checklist to make sure that all the tools are here, that everything's ready. And just a lot of the benefit is just getting the right people talking and getting people just used to being with each other and taking guidance. And so, I'd encourage you, this book, it's a wonderful read and it's short, but it's the 4 wastes are of not that come from not having design guidelines. There are many ways to do things in a company. If we're doing them many ways, one of them is going to be better than the others. And so there's a waste that comes just from the fact that we're not all doing it the best way. Okay, that's the first one. The second way is that new designers are out there, and I did this all the time. I didn't want to be doing it, but they're reinventing things that have already been done, and there are better ways to do it, but they don't even know what's out there. They don't know who to even ask a lot of times. If you come into a company new and it's not your boss or somebody in your immediate group, you don't realize that somebody in another factory 400 miles away knows how to do this. It might be a year before you meet that person. Another one is downstream colleagues. They spend, I put needless effort supporting multiple approaches. So think about your factory. I've got 5 different ways I fasten the same thing. I take that to my factory. My guy in the factory is having to accommodate 5 different ways to do the same thing. Even if none is better than the other, it's still having 5 is worse than having 1. And then finally, there's just no standards to continuously improve. Continuous improvement is based on having a foundation of standard work. Whatever it is, wherever you are today, that's your standard. And you just get that on paper and you keep doing that. Now, every time I can build on that standard, another step, you get an improvement. And then I can build on that and build on that. And I always like to say, Grandpa can climb a 10-foot wall if you give him a set of steps. but you need that, you need this, you need some kind of a foundation to build those steps on. So what problem are we solving? Oh, I don't think I changed this. I'm sorry. This is a repeat from the last slide. But yeah, I guess I must have copied it over. But it's the problem that we're solving, I'll just speak to it, is that there's a lot of knowledge in the organization that doesn't get used by people who need it. Information friction and that's the problem. And then the problem is the designs are substandard and have to be reworked, or we deal with extra cost or reliability issues to the life of the product. But the root causes are still the same. We're missing a method for thorough and efficient team review. And I think of this especially at design reviews. I used to go to design reviews and like, what's the agenda? Am I really just going to look at a stack of 100 drawings one by one? The answer is sometimes yes. But if I have design guidelines, now I have design guidelines to walk through, and I have somebody who's been an expert that set them up for me. And so, you know, this is a very simple example of the design rules. Like, think about a software team doing web development. So you have a bunch of people that are doing web development. Well, hey, let's just capture our best practices. Let's go sit for a day and write down all the good things we know about naming conventions, about how we deal with firewalls, about how we deal with ports. Let's go, you know, how do we connect to e-com systems? You know, whatever it is in web dev that needs to be done. You know, how I accommodate different resolution screens. Let's just write down the one best way we know today. Don't try to improve anything in the beginning. Just write it down the best you know. Is it working? Okay, now find a couple of weak links. Now solve those issues. Now we can go and improve our best practices. And every time we find a new issue, we can go build it into our design practices. And Toyota is a world famous example where they started with a few pages, which has now grown into something, a huge book of all of the design practices, so that people make fewer and fewer mistakes as they're doing new designs. We can do that and think about doing design rules, or let me see, I think the next slide will talk to this. Well, first off, let me talk to you about the way the process really works. So think about we're going to define the innovation, your CTO or your head of R&D defines, these are the main disciplines of my org. You know, I've got to have somebody who knows how to, manufacturing. I need the ability to manufacture. I need that to be one of my disciplines. And, Sally, she's the best at it. I'm going to appoint her as the owner of that checklist. Now, another one I have is electrical design, because we have a lot of problems. We manage a lot of power in our products, and I've got electrical power design. That's another one. So think of having 2 or 3 like that. Don't start with 100. Start with 2 or 3 of the technical areas that are most important to your organization today. There'll be time to add more later, but for the moment, start small, get some improvement. Build the first checklist, work with your colleagues, get them accepted, and then think of that SME, that subject matter expert that owns that, the expert owner, as publishing a quarterly version. So, and then think of that person, and this is where the real power comes in. That person is attending design reviews. Now, I want you to think of the difference. How many design reviews have you been to where maybe there's not even a real expert in the room, there's maybe just you and your boss going through the design, versus having the company expert who will come and dedicate a half an hour to go through their guidelines with you. Now, imagine the power of that. Number one, it can be done virtually so easily, so it's not like you have to travel a lot to support it, but think of the power. Number one, you have the company expert at the design review going through what the company expert has through consensus building and teamwork, but built the list of what we think are the best practices. They're going to come and apply those to your project. How many times are they going to help you not get stuck out trying to fix something at the last minute because they caught it in the design review? Now, that's helping you because you can take corrective action before releasing the design, but it's also helping the design expert because they're seeing, hey, that shouldn't be there. And then, maybe they'll see some feature in your product and they'll be like, we shouldn't have that. I need to go add a new design rule. So the design rules are evolving. Your product is improving. You're getting smarter because you're learning from the best, and the design rules are getting better and better. And the subject matter expert is being recognized across the company for being the best in that area. Now, here's the next cool part about these design guidelines. You can apply them at your initial design review. You can do it after, which is say before the real design begins, but where you have a concept review. Then you can move to a critical design review where all the drawings are done. You can apply the exact same design rules, that checklist, when you're doing that design review. Then you step over to the verification review, the validation review. So think of those checklists. They become like pillars in your design system, and you've got the best people, the best ideas in your company, and look what you've done to that information friction. You've cut it by a factor of 10 or 20 or 50, getting the best the company knows to the people that need it. So I've watched this work. It's really exciting to set this up. It's a small investment of time. And so, you know, I just can't recommend it enough. You know, what can you expect? Well, you can expect the organization to be constantly elevating their capabilities in design, whether it's in software or hardware, whether you're talking mechanical, electrical, optical, whether you're talking about chemical, whatever it is you're doing, you're constantly elevating the practices in your organization. And you have a comprehensive set of design reviews, and they're consistent. I would go to design reviews for one product, and it would really be a good discussion. There'd be like 7 people there, 1 person from the factory, 1 person from procurement, and you know, because the person sitting at the design review was really diligent. And then 2 weeks later, I go to the next one, there's like 3 people, and I was one of them, and I wasn't able to even really help much. And so, you know, just this huge inconsistencies in the design reviews across the org. You can eliminate those, get rid of the needless variation. And this is my favorite, build towering technical competence, because now your SME, well, what are they going to be doing? They're going to be thinking, hey, there's a conference coming up on my topic. I better go. I'm responsible for the organization's design rules. Hey, there's a webinar that's being given on a topic, or I need to go take a class at Coursera because there's an area I don't really understand a lot about welded fasteners. I'm really good at you know, at threaded fasteners. I need to go learn this detail, or I'm going to go take a vendor class, or whatever it is. But you know, you're encouraging them to go learn, and so they're growing like crazy. They're feeling the satisfaction of mastering their craft. You're putting out projects that don't have all these fires at the end. Customers are getting higher. I mean, it's just virtue. Everybody but your competitor wins. If you're interested in having a Kaizen where we get you started, we come and build 2 or 3 checklists with you and then set you off on the way to build a whole set of them over time. Again, download this and we're glad to help. And so the last one is on the 3P. In April, I'm sorry, I'm going, so I hope I'm going to try to go through the 3P fast, even though I love it to death, because I know we're running out of time. But the 3P is, again, a structured cross-functional event, and it's where we want to find the optimal design or the optimal process. And, you know, we learn in college all the time. Oh, give me, you know, I mentioned this earlier. The professor gives me a problem, and I give them the solution. But in real life, what happens is we get problems in our design or process. It takes a team. And how do you do that? Well, you could go ask people, and they'll look at it a little bit, or they'll look over your shoulder, or maybe they'll review it by email. But come on, you know it's not the same as when you get a group of people in a room and say, this is one of the most important problems we have to solve to be able to support this new technology that we're bringing out. We're going to bring the best in. We're going to sit for 3 days, and we are going to solve this problem. That's what a 3P does. It's a super creative process. You spend about the first third of the event learning about what the problems are, what's been encountered by customers in manufacturing, by competitors, what the promise of the technology is. All you learn. So the first third of the meeting, like a day, you're learning about the problem. And then you're coming up with ideas, and you're doing what we call tri-storms. Remember the old brainstorm where people would sit around a conference room table and toss out ideas, but they never really went anywhere? Well, in a tri-storm, what we do is we toss out those ideas, we group them together, and then we build teams that go out and build something. Very simple, just to demonstrate it. It sounds crazy, but I'm telling you, it works. Even for complicated designs, you can go out and tri-storm things amazingly easy. And the 3P is, it's so flexible. I've done 3Ps in 4 hours, and I've done 3Ps in 5 days. It just depends on the complexity and the importance of the problem. It's just a very flexible process, and it works across all disciplines. What are we trying to do? Our projects get stuck in design rework. We can't get the design completed. Customers aren't satisfied, or manufacturing impedes our launch. We put something out there and the design can't be produced well. What's the problem? Rework and manufacturability or functionality problems that limit our launch. And what do we need to do? We need a process that pulls a cross-functional team together for a few days to attack the company's most difficult problems. Like I said, we were doing maybe one or two of these a month. And we just hit a tough problem and we say, don't get stuck there. Let's go get a team of people. It's a very engaging event. I gotta tell you, it's fun. You come up with really cool solutions so people are proud of them. And so it builds a lot of engagement. Where can you use it? You can use it in new products. You can use it in a new business line. You can talk about it in a major improvement. You can use 3Ps in developing and deploying a new technology in your company. You can use it to relocate a process, and you can use it to increase collaboration in open innovation. In other words, I have this new manufacturer design house I'm working with. Use the 3P. It's a great way for everybody to get to know everybody. And you don't have like this, such a walls built up between you and your supplier of open innovation. Sometimes when you don't have a technology in a company, the fastest way to acquire it is to go through open innovation, learn it over 2 or 3 years, and then eventually bring it in. But during this period, I've seen such poor collaboration that people are on, they're hardly talking, maybe at the design handoff, and that's it. How does it work? Well, I already walked you through this, but we get a team, we define a measurable goal of our team. We go through and understand the functions, we create, we do an ideation, and then we go out and do these cool tri-storms where everybody is kind of showing off their own invention with whatever 3D printing, whatever it is that they need to go show that. And then we come together, we pick the best ideas, and we deploy. And that can take a few months to get all of that done, but the event itself is, like I said, between half a day short, let's say 3/4 of a day, 6 hours, and a week. We've got this done. And again, I know it's very much a working meeting, and they're just a ball. Definitely my favorite problem-solving tool that there is the 3P. And what can I expect? Getting my projects in on time, and less rework because of manufacturability issues, better customer experiences. And again, as you've seen, the theme through every one of these tools in the design to produce set is increasing the technical expertise in your organization. Make your products better, give manufacturing a chance to really improve and get efficient, make your customers happier and more satisfied with the result. If you're interested in 3P Kaizen, obviously you can tell I've got no lack of excitement for them. Let me know. They're easy to set up. Once you get the hang of it, I would say the first one is better to do in person while you're learning it because there's a lot of newness to it. But after that, you can go to virtual. And I told you we were doing 1 or 2 a month. I would say 80% of them, 75% were virtual. They're very easy to do virtually. When you do the breakout teams, those teams have to be co-located so they can do their tri-storm together, but that usually works out okay. You have to think about that to make that happen. But the whole team comes together, studies the problem as one group virtually, then we break into teams to go work on our ideas, and those parts are usually co-located, even not always, but especially if it's something physical. But anyway, the point is it becomes a super tool to add onto your tool set, and once you get the hang of it, it's very easy. So I hope you liked this webinar. If you did, I encourage you to go to these places. And one thing I'll mention is we do these monthly webinars. I also have the innovation journey, and if you'd like to sign up for it, I appreciate the help. I'm trying to get to 1,000 by the end of the year. I'm really close. So it's a weekly newsletter, although I've been traveling a lot lately, so it hasn't happened that much. But just very short 3 to 5 minute reads about what I discovered that day. And then a couple of books. If you really like this sort of thing and you like this approach, there's a couple of books here available from Amazon. And there's a ton of webinars on all topics beyond innovation at our website. So just go to Lean Focus and click on Thought Leadership. This is my favorite quote from Eli Goldratt. I love it. I start to count. People are good. Every conflict can be removed, and so on. And I love at the end, every person can reach a full life, and there's always a win-win solution. I really believe that, and these tools help that happen. So with that, April, I know I didn't leave enough time, but did we get any questions that might be helpful for folks?
We did, George. Thanks so much for a great presentation. And I think everyone can probably agree with me. Your enthusiasm is infectious, and that's how your events relay as well. So, one question did come in from Ashraf asking, would you characterize FMEA as a proactive tool rather than a reactive tool?
Oh, what a wonderful question. Yeah, it's both. So you can use it in the design process before you or the in the design in the development process before the product ever gets to the factory floor. Absolutely, and that's what I would say in my normal experience is doing that. That has some weaknesses because you're taking a lot of guesses, right? You haven't seen anything work. You're going to talk about what the problems are going to be on the factory floor, but you're guessing a lot. Now, the other way that they're used is as a reactive tool. When I have a product that has issues, and I've done this too, we've done a couple, I think at Lean Focus, we've done 2 of these over a 6-week period where there was a product in production and the quality issues were distressing. And so we went and did a PFEMA afterward. I'll tell you, it changes the whole flavor of the PFEMA because there's a lot less guessing about what might happen, and you gather a lot more factory data. So I see the PFEMA, and there's actually a model in the middle which says do it in the beginning, and then be updating your PFEMA, every month, looking at new quality issues, and just make it a continuous process. So I would say it's proactive, it's reactive, and it also can be continuous, sort of the space between those two. Great question.
Great. Well, along those same lines of FEMA, how do you keep the FEMA from evaluating every imaginable possibility? It seems like you could spend a lot of time on very unlikely scenarios.
Well, that's exactly a problem. So, that's the problem with PFEMAs, and that's why we structure them. So you're always, you're either doing cause and effects matrix or you're looking at factory data. So you're starting with the most difficult problem. But I'm going to tell you guys, there's one part of the solution that which is pretty tedious, which is in the beginning, people have all this appetite to look at all these crazy things. What happens if I buy a bolt where the head comes off? Okay, have you ever seen a head come off a bolt like that? No, never happened. It's a 5/8 inch bolt. Never seen it, but it could happen. And by the way, the bolt is oversized by a factor of 10 to 1, and so it's all so unlikely. But you could spend a half an hour on it. And so one of the things we try to do is, like I said, if you haven't built the product, use the cost and effects matrix. That guides you to the most important areas first. Otherwise, if you have built it, use factory data. Now, here's the cool thing. People run out of that kind of energy really quickly. About 3 or 4 hours in, it starts getting hard. And then people start getting more focused on the most important things. So there is a little bit about that in the beginning, which we try to wave off. But people naturally feel, it's difficult. I told you it's not the most fun event. And so what happens, April, is people just naturally start to say, like, in the beginning, this was fun. I want to look at everything. But then about a day and a half in, they're like, I want to get this finished up. Come on, let's go cover all the critical stuff. And so there is a natural focusing that just comes by getting everybody together. And I have seen people try to do FEMAs over long periods of time, and they don't have the benefit of that, okay, we only have 3 days. And I have seen that turn into a lot of trouble. So I would say keep the event short, concise.
But George, you mentioned earlier about it's a little bit painful to go through the FEMA process, but is it better to just get it all done in one go versus dragging it out and facing the consequences over time?
Yeah, because if you try to do it like once a month or something, little pieces once a month, which I've seen people do things like that, it's like you never get out of that high energy state and you're always looking everywhere. Yeah, I think you want to have a definite start and a stop to a FEMA. And I would say, of all the events, I would say it's better in person. Virtual events are hard to run like that. We typically do virtual events 2 hours every other day or something. I don't think that's a great format for a FEMA. I think FEMA really belongs in person because of that.
Now, this question is asking about 3P. How do you know when to hold a 3P?
Oh, you learn it. I will tell you, it's hard to describe because I started using it when I was like in crisis mode. We were going to miss a date because we didn't have a design done, and we knew we had to have the design done, and the drawings weren't being completed, and we knew we had a crisis. So we're like, oh my gosh, we got to react with a 3P. But the more you use it, the more you start understanding when is a team in trouble and isn't understanding a design and needs to pull that cross-function that cross-functional group together, because people don't do that naturally most of the time. And so as a leader, the more you use the 3P, the better you get at picking out the places where it can be used. And it's so much more fun when it's not a crisis, but I can do it in the normal pace of things, so I can take my time and prepare well and have a much more managed event. So I think part of it is, rule number one is, if I see anything technical that's holding up a project, my first thought is 3P. Second is, when you get used to it, you'll start to see the flow of it.
That's great, George. Okay, one last question. We need design guidelines for a lot of areas. How do we start?
Well, that's a question I get a lot, because when I go to people and I say you need design guidelines, the first thing I usually get is, well, we've got 15 different technical areas of expertise in our organization. So should we do all 15? And I would say the first place to start is start with your manufacturing team. And I'm speaking if you're in hardware here. So go find out the things that drive them crazy. That will be a great place to get a beginning. Your SME may be somebody from operations that has expertise in bringing new products in. A lot of organizations have a person like that their whole job is just to integrate new products into the manufacturing environment. And that's a really simple one, and it pays off super fast. And then, I then start thinking about, where am I having the most gaps? Where am I having the quality or the customer complaint issues? I guess what I'm trying to say is think of a guideline as attacking your most valuable problems versus trying to just put out like this whole, web across everything you do at once. Get better to go out and do a little bit, get some payback, learn how to do it, and expand.
All right, George, a couple questions have popped up. So for those who want to stay, great. This question comes from Vicky. Vicky asks, how did you motivate your R&D team to embrace the lean methodologies?
Oh my goodness. Well, that's a great question, and I love talking about it. I would say the first thing is I had a lot of management support. So I had goals that were passed down to me from my management. Number one being projects were going to be on time. I was able to convince my team, hey guys, we got to get these things on time. The management's serious. And number two, these are the lean techniques that work. I've seen them work, and so they had to believe enough to follow me. I would say the third thing that comes to mind to that question, and that's such a deep question, I imagine I'll think of 3 other things in the next hour, is I went to Gemba a lot. So if I had a project that was in trouble, I was in the design review, I was in the weekly meetings, I was out in the factory floor visiting the customer. So I really felt I understood. John Shook says that lean leaders are the ones that go down, see the work, and help. And I always looked at it as like, I've got this great group of guys, and I keep saying guys. My team was a fair amount. We had a pretty good mix of men and women, but we had a team. They were great, and I always felt like if I could just help take out a little bit of waste, that'll let them go be the person they were meant to be. And so, for me, that fed me to keep me going down and doing that and staying very involved. I would review every project every month. And I would, it was just, I felt my job was just to be with them. So those are the 3 things that come to mind: management support, using the method and piloting it to prove it before you do it on a large scale, and then going to Gemba, because whatever you do, it never works. It's always off by a little bit, and you got to correct it. It basically works, but it doesn't work enough to just let it go. So I would say those are the 3 things. That's a long answer to a short question, but thank you, Vicki. I love that question.
Oh, thank you so much, George. And then last question is from Gil. I understand the concept of 3Ps, but what does it stand for?
The name is not a great name. It's production, preparedness, process. And it was originally used on the process line. So it was really intended for the factory when somebody was building a new cell. And so those are called process 3Ps. What I did as a R&D leader, took the exact same workflow, the exact same, almost the exact same PowerPoint deck, as defining my process, and applied it to design. So 3P it's really not, you could still say it's, I would say it's more than production preparedness when you move it to the design. It's really the entire product fit for use when you apply it at the design level. So 3P, not the greatest name, but that's the name that Toyota gave it. So that's the name that's stuck over the years.
Thank you so much, George. Well, I want to just thank our audience for joining us and sticking with us through the question and answer segment. Really great engagement. George, just want to thank you so much for an excellent presentation. And yeah, so for everybody out there, just keep an eye out if you'd like to watch this again or share this with your team. A recorded version of the link will be sent out in about a day. So thank you all so much for joining.
Thanks, everybody. Bye-bye.